Hello, we are going to take a look at a real-life example of the composition of functions by using an example from nursing. We have a practitioner who orders 10 milligrams per kilogram every 8 hours of amoxicillin with a concentration of 400 milligrams per 5 mLs for a child with strep. The child weighs 44 pounds. The nurse knows the following formulas to calculate the correct amount of mLs to administer to this child. Use the formulas to calculate the mLs to give to this child. In order to do this, we'll start with the first formula, converting the pounds to kilograms. The child weighs 44 pounds. We'll divide that by 2.2 to find that the child weighs 20 kilograms. And so then we're ready to go to our next formula, where the dose equals the order. So I'm going back to my problem and see the order right here. So 10 milligrams per kilogram times the kilograms, which we calculated to be 20. Kilograms cancels, and we get 200 milligrams. Our final formula says to take the dose, which is what we just calculated, at 200 milligrams, divide it by 80. And when I do that on my calculator, I end up with 2.5 milliliters. Take a moment to see where that 80 comes from. If I look up here at the concentration of the medication, it is 400 milligrams per 5 ml. So if I just take 400 divided by 5, that gives a concentration of 80 milligrams per ml. And so the 80 that is used down here comes from the information given. Our goal then is to write a new formula that directly calculates the milliliters to administer based on the weight of the child. So this right here, this writing a new formula, this is where we're using the composition. And to do that, we want to calculate milliliters directly based on the weight of the child, and the weight originally is given up here as 44 pounds, so based on pounds. The way that we do this is to plug one formula into the next, So our final formula that calculates milliliters is given here. I'm going to replace dose with the formula for dose. So in this formula I have this divide by 80. Now up top I had dose, but instead of dose I'm writing order times kilograms. So cleaning that up a little bit, the order we had found in the problem was 10. So really this milliliters based on pounds is 10 times the kilograms divided by 80. But kilograms is not the same as pounds, so I have to do another substitution. So I need to replace the kilograms with the formula for kilograms. So that's what goes in here. So again, a substitution, milliliters based on the child's weight in pound will be 10. Instead of kilograms, I'm writing the formula for that, which is pounds over 2.2. And then that is divided by 80. So this is my new formula. And instead of having to go through all the different steps that we went through, getting answer, we have one formula that does the entire thing. So if we try this on our calculator, we'll do 10. We'll do 44 divided by 2.2, and then divide that whole thing by 80. And we do indeed get the 2.5 mLs. So this work that we did in the second part, where we substituted one formula into the next, is the composition of functions.